All right, welcome back to Mr. P Helps with Algebra. This is Unit 2, Topic 2, Lesson number 11, which is once again explaining models for linear and exponential models and how they can be used for real-life equations. All right, so the first thing we're going to do is look at linear versus exponential. Describing words the rule for each type of growth. So we know the linears in this case, it looks like this, and exponential looks like this. So identify the kind of sequence. Linears are always arithmetic, and okay, pen's not working so great here. And exponentials are always geometric. That's always the way it always works out. It's always multiplication, and in this case it's going to be multiplied by 3. So the first term is 4 because that's given right here, and every term after it is going to be 3 times greater. Second, third, fourth. So 3 times that would be 36. 3 times this would be 108. And 3 times this would be 324. All right, so for the arithmetic model, the first number is 4. That's the starting point. And every number after it's going to be 3 greater than that. 10, 13, and 3 greater would be 16. 2, 3, 4. Okay, so now when I'm going to be doing my graphs, I'm going to have a little bit of issue with the exponential because the numbers get so big so quickly. This one's not going to be too bad. So the 0th term was 4. 1, 2, 3, 4. I can make each box worth 1. The first one's going to be 1, 2, 3, 4, 5, 6, 7. And the next one's going to be 3 above it, which is right here. So there's your equation right there. All right. Then over here for exponential, I'm going to have to come up with increments that are greater because the numbers go all the way up to 320. So I'm going to make each block worth 10. So the starting point is 4, so that's going to be way down low. The next number is going to be 12, so that's right above there. The next number is going to be 36, and then the next number would be 108. So let's see, that's 3, 4, 5, 6, 7, 8, 9, 10. That would be like right there. So that's good enough for me. There's my hyperbola looking like that. So it's not a straight line. It is curved like this. It is a hyperbola. All right, so once again, as I mentioned before, we're going to look at a real-life situation. We're going to be looking at population. And this really is a real-world question because this is how the population really does grow in real life. All right, so in this question, I don't have a graphing calculator on me, so I'm at a severe disadvantage. You need to have a graphing calculator. We're going to let X, you can read the question right here if you can't see it. The U.S. population in 1910 was 92 million. These are real facts, by the way. 1990, the population was 250 million. Well, obviously, it's 2016. I believe the population in the United States is about 325 million. It might actually be slightly higher than that. It's been a while since I checked. We're going to let X represent the years since. It's important whenever you're doing a real-world problem to tell us what you're representing things. It's going to be years since 2010. I think that's what it was. No, 1910. Sorry. 1910. All right, so the pen's not working and I'm writing very, very sloppy here. Let f of x, the answer is always going to be the population in millions. Okay? Really, this has got to be my worst handwriting ever. All right, so the linear equation. Now, this is where you're going to then, I'm going to go by tens. It says here you can go by any intervals you want. I'm going to choose to go by tens, 1920, 1930, 1940, all the way down to 1990. So we've got 92 here, 250 here. You can use your arithmetic means. Add the two numbers up and divide by 2, and that's going to give you the number in the middle, and just keep doing that until you've got all the numbers. Now, like I said, I don't have a scientific calculator on me, so I'm at a severe disadvantage. I can't show you all of this. So you're going to find out what the arithmetic sequence is, and I'm just guessing every 10 years it's going to be increasing by, like, give or take, I don't know, 18 million or something like that. I think it's slightly less than 20. I'm just eyeballing these numbers right here. So use a calculator and you can determine it on your own. So you can find the difference. So 250 minus 92, so that's going to give you about 150. Divide that by how many patterns? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I think I came pretty close there. So all you got to do is your division. So this one's going to be pretty crazy over here, exponential, because you're going to get a rate of like 1.0 something. It's going to be a really long decimal, and you want to keep at least 3 significant digits. Otherwise, you're really going to change these numbers right here. So you're going to divide 250 divided by 92, which is going to give you like 2.6, 2.7, I want to say in that range. And take that number 2.7 and then do the 1, 2, 3, 4, 5, 6, 7, the 8th root of 2.7. So that's going to give you like some really crazy low number that's like 1.05 or something like that. But like I said, keep at least 3 digits after the decimal. Once you found that number, then you can just multiply 92 times that number, and you should get pretty close to 250 in the end. And then you've got your equation. All right, so then you can, once you've filled out all this information right here, then you can compare the actual data to the predicted data. And when you look at this, you should notice that the real data, because I told you this is all real numbers, the real data should be close to the exponential model because population grows exponentially. It does not grow arithmetically. So that's just the nature of the way the world works. The world always population grows exponentially. All right, so it should be a much closer population. So if you were going to predict 2030, the year 2030, I would definitely use the exponential model, and that's kind of interesting to do. So if you do that, put it in the graphic calculator, look at 2030, which is like 120 years after 1910. So you look at 120 for the x, then figure out the answer and see what the population is going to be. It's probably going to be like 350 million. It might even be more than that. So it might be more like close to 400 million, which, you know, how many people... I mean, that's a lot of people. That's too many to think about. All right, so getting to the homework. All right, the first question is actually something for the future. So we're looking at the triangle stages. This is 1 triangle, this is 4 triangles, this is 9 triangles. The 4th stage would have been 16 triangles. And the reason I'm doing that is because the equation is y equals the stage times itself. So that's x squared. So this is actually a quadratic equation, which I know we haven't done yet. But it's pretty basic. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. All right, so I've got this. The first term is 1, the second term is 4, the third term is 9, the fourth term is 16, and that means the 5th term would be 25. And then I can graph those numbers over here. Now, in order for these numbers to fit, I'm going to have to once again make these increments. So I would go like by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that way I can at least fit the first 4 numbers. So the first number is 1, so it's going by 2, so that would actually be right here. So I'm going to go 2, 4, 6, 8. I'm going to call this 10, and this is 20 up here. So the first number is 1, which would be about right there. 2 is 4, 2, 4, right there. 3 is 9, which would be right there. 4 is 16, which would be about right there. Now, I know what you're thinking. Most of you are probably thinking, hey, that looks like a hyperbola. It's not. It's actually the right-hand side of a parabola. It's actually, this is going to make a U shape like this. It's going to have a minimum amount. It's going to have a lowest amount. Whereas hyperbolas don't really have a lowest amount because they have what's called an asymptote. So they never have a lowest amount. All right, count the squares in each of these stair steps. Write the explicit equation. So this is counting squares. That's 3, 2, 4, 5, 6. 2, oh, I'm sorry, 2, 4, 6. Yes. 2, 4, 6, 8, 9. It looks like 9 there. So it looks like it's adding 3, so that makes it easy. It's an arithmetic sequence. And if it was over here, it would be 0. So that would be just simply y equals 3x. 3 times the stage equals the total amount of blocks. 3 times 2 is 6, 3 times 3 is 9, and so forth. It works. All right, so table 1, 2, 3, 4, 5. All you have to do is multiply by 3. 3, 6, 9, 12, 15. Graph it. Once again, I'm going to have to be a little creative on my graph because if I want to go up to 15, I'm going to go by 2's again. 2, 4, 6, 8, 10. This would be 20, and there we go. 1, 3 would be right there. 2, 6 is here. Okay, that didn't show up. 2, 4, 6 right there. 3, 9. 2, 4, 6, 8, 9 right there. And you can see it's going to make a straight line. All right. Thanks again for watching. Give it a like if I helped you learn something. And definitely subscribe if you haven't done so already. Have a great